So in this video, we're going to just discuss about how do I simplify monomials that have negative and zero exponents. So last class we got really good at simplifying monomials, but they didn't have negative exponents and they didn't have zero exponents. So think about it. We're raising something to the -2 power. So that means that we're multiplying something by itself -2 times. What does that even mean? So before we start simplifying this, we have to go back to what the meaning of a negative exponent means. So if you have a to the -2, this just really means you have a multiplied by itself twice, but it's on the denominator. So it basically looks like this. Now, similarly, if you have 1 over a to the -2 power, this just really means that you have a multiplied by itself twice, and it's in the numerator. So if you notice, it's basically, in order to get rid of the negative exponent, you just basically make it into the reciprocal because they mean the same thing. Now, a zero exponent, if you have a to the 0 power, this just really means 1 because what you have in the numerator and the denominator is canceling out to 1. Okay, so let's go ahead and use that in order to simplify things that have negative exponents. So before we start, we need to go ahead and remove our negative exponents by the meaning of them. Get rid of these and get rid of the 0 power as well. Now, the -5 is not a negative exponent. It is a negative coefficient. So we are not going to change this to reciprocal. We're going to treat it like a number. So we're not touching this whatsoever. Okay, so this is going to come out to be 3. We're going to leave the b to the 7th exactly where it is. And then z to the 3rd, again, is going to stay on the numerator. And then now we're going to have this -5a z to the 5th a squared. It's going to stay exactly where it is because, again, it doesn't have a negative exponent. Now, the a to the -2, we're going to change that into a squared, but now it's going to be on the denominator. We're going to make it into this reciprocal. And so that will undo that negative sign. And now this makes a little bit more sense. It's just a multiplied by itself twice, but it's on the denominator. And then b to the 0 is just a number 1. So yes, we can go ahead and put times 1 here, but we don't need to go ahead and do that because it's kind of redundant. Now, if you had nothing in the numerator, we'd put the 1 in there to kind of clarify that we have a 1 there. Okay, so now that we have gotten rid of the negative exponents and the zero exponents, this is exactly a type of problem that we did last class. So on my numerator, I have 3 and times b to the 7th times z to the 3rd, which I can't really simplify any further. But in our denominator here, we can go ahead and expand this long monomial here that says -5a z to the 5th a squared multiplied by itself twice, right? So -5 times -5 is going to just be the number 25, positive 25. A to the 2nd times a to the 2nd is going to just be a times a is just going to be a to the 2nd, sorry about that. And then z to the 5th times z to the 5th, how many times am I multiplying z by itself? Well, 10. And then a squared times a squared is going to be a to the 4th. Okay, now that I have expanded that, we can go ahead and multiply our denominators by putting bases together. So a squared times a squared times a to the 4th. That's just going to be a to the 8th power. Now, 25, there is no other coefficient to go ahead and multiply 25 by, so it's just going to be 25. And I always like to put my coefficients in the beginning. It just looks better. Again, you can put times a to the 8th times 25, but it looks kind of funky. And then I have this z to the 10th that is not being multiplied by anything, so it's just z to the 10th. Okay, now let's go ahead and see if we can divide anything out. 3 divided by 25 is just 3 over 25, so you can't even simplify that. Okay, now my b to the 7th has no b's to divide by, so it is what it is. The a to the 8th, again, we just write it There's no one to simplify that with. But the z to the third divided by z to the 10th is z to the 7th, and you have to realize, well, it's on the denominator because I have more left in the denominator, so it's going to be z to the 7th on the denominator. You could have put it in the numerator as z to the negative 7th, but that wouldn't have been completely simplified because we don't like to have negative exponents, again, because going back to the meaning, what does it mean to multiply z by itself negative 7 times? Well, it's the reciprocal of it, so it should go on the numerator, the denominator. And that's it. This is about the most that I can simplify this to. There's one of each variable. There's no negative exponents, no zero exponents, and my coefficients are simplified, so this is completely simplified. Okay, now let's do one more example. So here I have that this whole entire monomial is raised to a negative exponent. So the first thing I think I would want to tackle is having this negative exponent and going ahead and making it the reciprocal to make it all a positive exponent. So my numerator is going to be 5a to the negative 3, b to the 7th, c to the negative 7th. My denominator is going to be 2a to the 0, b to the 2nd, c to the 5th. But now it's raised to the positive 7th power. And then you're probably thinking, okay, wait, I still have negative exponents. Well, okay, so now we're going to look at the inside of this, and we're going to change that around. So we have this negative exponent here on this edge, this negative exponent here, and this zero exponent here. I always like to start by rewriting everything again, so that stays. So b to the 7th, 5b to the 7th kind of stays where it is, and 2b to the 2nd, c to the 5th stays where it is. Now, the a to the 3rd is going to come on the denominator, and now it's going to be an a to the 3rd instead of a negative exponent. And the c to the 7th, again, we're going to write it as its reciprocal, move it down. A to the 0 is just 1, so again, I just don't need to even write that down, and that's about it. So now I have a problem like I had last time in the class. So again, we need to square this entire monomial. We're multiplying it by itself, so let's go ahead and do that. And so I'm going to have on my numerator, again, let's get rid of those parentheses because we don't need them anymore when we square them. So we're going to do 5 squared, which is just 25. B to the 7th squared is b to the 7th times b to the 7th, which is b to the 14th. And then 2 squared is going to be 4. B to the 2nd times b to the 2nd is just b to the 4th. C to the 5th times c to the 5th is c to the 10th. A to the 3rd times 8 to the 3rd is just a to the 6th. And then c to the 7th times c to the 7th is just c to the 14th. Again, notice that with the exponents, what we're just technically doing is multiplying by 2. And then this is 2 to the 2nd, which is just 4. And then again, so just keep in mind that that's the power to the power rule, but you don't have to think about it that way. You can just think about it as just your products rule. Okay, so now that I can have this, I'm going to see, is my numerator simplified, which it is. The denominator is not simplified. So if you notice, I have c to the 10th times c to the 14th, which I can go ahead and make into c to the 24th. So I have 25b to the 14th on my numerator, and then over 4b to the 4th times c to the 24th, a to the 6th. And then let's go ahead and divide now. B to the 4, 25 over 4 does not simplify, right? But the b's do. B to the 14th divided by b to the 4th, it's just going to be b to the 10th. And then c to the 24th, it's going to be on my denominator, and a to the 6th on my numerator. I'm also on my denominator, sorry about that. That's about it. Okay, so this is the end of this video. So this is how you would go ahead and simplify something that has a negative exponent. So again, it's pretty much the same thing as what we were doing last class. The only thing is you have to go ahead and think about, well, what does a negative exponent mean? It's just the reciprocal of it. And so it just means it would be on the denominator, right? And also, what does an a to the 0 mean? Well, you have to go back to the meaning of that, which is 1. So I hope you found this helpful, and you can do it on your own.